Hey folks, this is Tyson with the first TCon video coming at you on the topic of elasticity and microeconomics. So let's unpack what this very difficult micro topic is really all about. And in order to do that, we're going to start by thinking about basic principles of elasticity. We'll take a good long look at price elasticity of demand. We'll look a little bit at other types of elasticity, and then we can think about factors that make a demand for a good more or less elastic. And then we'll look at the context in which elasticity has shown up in a few of the AP micro practice problems from past examinations that we maybe have looked at in class. At any rate, elasticity, the core of it, what is it really about? It's all about the concept of responsiveness. So anytime you see the word elasticity, you can think of how it relates to responsiveness, and you'll be well ahead of the curve on that one. Price elasticity of demand. That is the main kind of elasticity, the one you have to know tons about, and it can get kind of mathy. And you're capable of doing it though, because really it's just focusing on the question, how responsive is quantity demanded to a change in price? And we already know some things. We know that quantity demanded changes inversely with price because of the law of demand. The income affected substitution effect and the principle of decreasing marginal utility tell us that the higher the price, the less we want to buy. And the lower the price, the more we want to buy. But how much less and how much more? And elasticity is there to help us answer this super important question. And it's useful for economists in measuring consumer behavior, and it's useful for firms if they wanted to know how much more would I sell if I cut the price by 10% or something like that. So we can think about all those things. And in order to do that, we got to introduce what, first of all, is going to look like a kind of yucky formula. So let's walk through it a little bit. It's the price elasticity of demand coefficient formula. So we can call this guy ED, E sub D, for elasticity of demand. So it is percent change in quantity demanded divided by percent change in price. That's the formula right there on that left side of the equal sign that you're going to see in all the textbooks and all the study guides and things. But I think a super helpful way of messing with that formula, and I've manipulated and mathed it out algebraically, and people who know more math than me have told me that I'm not breaking too many rules. So it's P divided by Q, price divided by quantity, times 1 over the slope. So let's sort of think about that a little bit in a minute. But we'll park that formula aside, and we're going to think about a couple of demand curves that we have here. So we're going to slide that formula on down. We'll take note of it later, and we'll mess around with it a bunch during this video. But on these two demand curves I have, let's just think about a couple different prices. So here's an initial price and a second price. And for the purposes of this right now, we go ahead and think of this as a price decrease. So we're going to think about that top line as the first price. And of course, over here, we wanted to buy this many. And over here, before the price change, we wanted to buy, that many right there. Put it in the middle of the line, why not? Okay, so once the price decreased, people wanted to buy more of both these two different goods. But how much more? Well, over here, we wanted to buy a little bit more. And over here, we wanted to buy a ton more. So over here, consumers were more responsive to the change in price. And this is just a massive increase. Whereas over here, it's an increase. Right? Due to the same change in price. Maybe it's two different goods. We'll come to conclusions about the types of goods, but you might even have some ideas if you pause it and think about your own buying behavior about which things a change in price would affect you a lot or just a little. So we could say that this demand curve over here is more elastic, and this one over here is less elastic or more inelastic. But the story gets more complicated. Here's how the plot thickens. This value of ED that we brought down here, this formula I introduced and only explained a little bit, we'll park that a little bit closer in here. And that value changes along a demand curve, even if that demand curve is linear. And all the assumptions we'll make here will be with linear demand curves. It makes the math a little bit easier. And most of the time you have to calculate this on an AP test. The math's not too hard, and you could do it with one of these two pretty easily. So let's go ahead and kind of walk through how we would do that. All right. I have a sample demand curve here, and the questions that are driving my analysis right now are how does price elasticity of demand change along the linear demand curve? What does that tell us? and why does ed change along that demand curve? So first, let's think about this demand curve we've got here. And I have a demand with a downslope, linear downslope, right? Every time the price goes down by $1, 100 more people want to buy one. Okay, and we could start by thinking about what that value of ed would be at various points. We could try to calculate it or whatever. We know that the slope here is always negative 1/100th. And if we were to take P 500 over Q $5 and multiply it by 1 over negative 1/100th, or basically multiplying it by 100, we're going to get a value of -1. Ed will always be negative, but economists by convention will drop that negative sign and then compare the resultant value to 1. And if we compare it to 1, we find out a couple of interesting things. We'll know either that value is going to be greater than 1, and then we can infer all of these things right in here about demand for that point or range on the demand curve, or we'll find out that it's less than 1. We can infer all of these things. Those will go with points in the bottom half of the demand curve, or we'll discover, hey, it's a unit elastic point. And for any linear demand curve, that turns out to be the midpoint between the price intercept and the quantity intercept. And that's the one that's marked here in green. So thinking about this stuff with MR and TR, that's kind of important to connect in here a little bit. So here what I have are a series of boxes that represent the total revenue that a firm might earn if it sold that many units at that price. Or you could say that we would spend our total expenditures. It would be price times quantity. So here, let's say maybe this would be at a price of maybe $9. Okay, so $9 times 100 units, that'd be like a value of 900, that area in there. What if the firm said, well, hey, maybe I should decrease my price to say like $7. Here we go. So now let's model $7. Well, they'd sell 300 units at a price of $7, and that would be $2,100. So total revenue's increased. And you can see that because this box here is smaller than this one. So as quantity increased, the size of that total revenue box that's inscribed inside the demand curve is P times Q, that size of the box increased. Now, two things happened to it. Okay, you can see here this area was added to it because we sold 200 more units. So the box got bigger because of what we call the quantity effect. However, this little bit up here got snipped off because now the price is 7, so we're not getting those $9 for those first 100 units this week since we made 300 or something. So this part decreased because of the price effect. But in this elastic range, the quantity effect is dominating over the price effect, and so on net, total revenue is increasing. Marginal revenue is how fast is total revenue changing, and is it changing? Increasing, then marginal revenue would be positive, or is it decreasing, then marginal revenue would be negative. So that's the rate of change of total revenue. And you know marginal is always the rate of change of something or the slope of it. We'll look at that in a second. Suppose the firm said, what about at $6? Well, $6, 400 units, that's $2,400 of total revenue. And that's this box here. It's still getting bigger. You can see quantity effect, this amount versus the amount we snipped off up here. This amount over here is larger. Okay. We've discussed the green box, but it's noteworthy right now that the green box is the largest one you can inscribe in there. Suppose maybe like $4, 600 units, back to $2,400 worth of revenue. And we could continue on down. You could see now the box is getting smaller because this quantity effect part we're adding is dominated by this price effect part that we're snipping off the top. So because we're knocking the price down $1, but it's on a whole bunch of units, that tends to have a greater effect pushing TR down than adding this little bit of quantity at a low price. So you can see here that box is getting smaller. And of course, if I decided to sell 1,000 units and charge a price of 0, well, you can do the math multiplying those out pretty easily, and you can tell that I would have no total revenue at all. Well, let's map out what that total revenue would look like for every quantity. And it would be something like this downward opening parabola that you see down here. And we'll go ahead and just make clear that the 500 units here is the same 500 units that's there. And in fact, this is mapping out the area on the upper graph. So any size of the box, the biggest box was $2,500 of area. So we would have had a point like 100 and 900 for that first box, and maybe 300 and 2100, and then 420, 400, and so forth as you work your way that way. If we're comparing points within the elastic range, the lower one with a greater quantity will go along with higher total revenue. For comparing points that are within the inelastic range, then the higher one, the one that's closer to that unit elastic point, will go along with having higher total revenue. So that's some of what ed tells us. Now, why does ed change along the demand curve? Let's sort of think about that. It's easier to think about it starting with this formula. Does the slope change of that line? No, it's linear. Does P change? Does Q change? Well, sure they do. Okay, up here, P is big and Q is little. And big over little gives you big in fraction world. So way up here, the value of ed would approach infinity, and ed's value would decrease approaching toward 1 right about here, assuming absolute value of ed, of course. As we go down toward the bottom part, though, think about what's going on there. Here, price is pretty low. Maybe price is $1, $2, $3, something like that. So we're dealing with a small numerator, but quantity is huge, 800, 900 units. So Q is big, and little over big in fraction world gives you little. So that's why ed is actually decreasing to the point where it approaches 0 right down at this bottom point on the demand curve. And it just so happens that it always equals 1 right there. So that's a bit about how you calculate elasticity of demand coefficients, otherwise known as ed. So let's think there's other kinds of elasticity, though, and they just measure different types of responsiveness. So a quick crash course on those. Here's a question. Cross-price elasticity of demand helps us answer this question. How responsive is the quantity demanded of one good to a change in the price of another good? And the formula for that, if you notice here each time, if you kind of derive the formula from the question, how responsive is quantity demanded to a change in price? Numerator, denominator. Come back over here. What's the numerator? Quantity demanded of our main good, good X. What's the denominator? Price of our other good, good Y. So what we're doing is we're kind of testing how related are those goods. And depending on what we get as a result of that test, we'll know if they're complements or substitutes. And economists go further than you have to about measuring exactly how substitutable they are. But if we do my quick little test on this one, I always think about two relationships. I'm looking for substitutes and complements. Well, I know Coke and Pepsi are substitutes. What would happen if the price of Coke went up? So there'd be a positive change in our denominator. Well, some people would switch to Pepsi, and we'd have a positive change in our numerator. And so the positive over positive would give us a positive value, telling us those goods are substitutes. Flip it around, if we increase the price of peanut butter, people might buy less jelly because they're going to have less peanut butter and jelly sandwiches. The peanut butter and jelly experience is more expensive than it used to be. Those are complementary goods, and we notice that they move in opposite directions. So that tells us the negative value means that the goods are complements. That's what you need to know, really, about cross-price elasticity of demand. It's all about the sign, so don't take the absolute value of that one because you'll destroy the meaning of it. Income elasticity of demand is another one, and that's going to answer the question, how responsive is the quantity demanded of a good to a change in income? We know change in income affects demand curves, but up until we have this tool, we're only guessing, as economists, what people think maybe is inferior and what they think is a normal good. But with this tool, we can measure that. If you recall back to macro, you might remember that sometimes we used Y for income, and you're resisting the urge to ask why we do, and I'm resisting the urge to ask you why not. Um, but this is the percent change of quantity demanded over percent change of income. And notice again, it's numerator over denominator. Really, it's always percent change of quantity in the top of the fraction. So that's one universal across the types of elasticity. And that helps us determine if the good is normal or inferior. If you got a positive value, you'd know it was a normal good because that person got a raise. That's an increase in their income, and they bought more of something. That's like almost everything we buy. But if you got a raise, would you buy more or less generic toilet paper? And I think we all know the answer is less generic toilet paper. So that means it's an inferior good, and that allows us to judge that based on consumer behavior rather than our assumptions about a good. So price elasticity of supply is sort of the last one that you need to know a touch about. And that's answering the question, how responsive is quantity supplied to a change in price? So really the same idea as price elasticity of demand. And you could deduce the formula from that question. For me, it's probably easiest than memorizing 4 different formulas to think about that question and understand the question coming out of the type of elasticity. And then from the question, I could end up putting the formula down. And most of the time, it's just about knowing which direction something's changing. Although with this one, you would want to compare it to one to say elastic or inelastic. We'll look at an example of that in a moment. All right, so here is a question that we have, and these first couple parts here in part B ask us to think a little bit about elasticity. So with part 1 there, is the demand for good X relatively elastic or unit elastic or perfectly inelastic when the price decreases from 30 to 20? So how would we kind of do that? Um, One thing we could do is think about that total revenue test idea. If we refer back, we can think of the fact that we know total revenue is increasing as quantity increased if we were in the elastic range of the demand curve. Well, let's think about it. Quantity increases from 1 to 3. Price decreases from 30 to 20. Quantity increases. Let's see what happens to total revenue. If it increases, we'll know demand's elastic. And if it decreases, we'll know it's inelastic. Well, 30 times 1 is 30, and 3 times 20 is 60. The total revenue increase? It did. So demand is elastic. We're in the relatively elastic range of the demand curve. Is the supply of good X relatively elastic, relatively inelastic, unit elastic, perfectly elastic, or perfectly inelastic, and the price decreases from 30 to 20? Well, goodness gracious, this is an interesting case. The quantity supplied didn't change at all. So I think my formula, percent change in quantity supplied over percent change in price, is probably what I want to use. Then I have no change at all in quantity. So the numerator is 0. Doesn't matter what my denominator is, that fraction's going to be 0. If you get a value of 0, you know that we're talking about perfectly inelastic. And perfectly inelastic is a vertical line. Just think about what an inelastic demand or supply curve looks like. They're steeper. So if you kept going as steep as it could get, that would be vertical. A perfectly elastic demand or supply curve is horizontal. So that would be a situation where price was constant. You could take a look at that if you scribble out a graph quick and just keep going with price and quantity combinations. You'll notice supply looks kind of like a vertical line. So that'll tell you it's perfectly inelastic. Assume the income elasticity of demand for a good is -2. Show the effect of an increase in income on the price of the good. Well, you better process that and know that that's an inferior good. So an increase in income would cause me to buy less of it. If my income increased by 10%, I would buy 20% fewer good Y units. So that tells you that you should know to shift demand to the left on your graph for that simple problem. Okay, thinking about the different goods we buy, what determines whether we have elastic or inelastic demand for them? One thing that's really important if you think about a good is if the price rose, what other things could you buy instead that would take care of those needs or wants? And if there's a wide range of substitutes available, you would probably switch to another good that did the same thing. If there weren't, then you might just be stuck having to buy it. So over here, you might think about uh, all the different types of cooking oil that there are. And if canola oil got more expensive, we'd buy a lot less of it. We'd buy corn oil or vegetable oil. Um, on the other hand, over here, um, there's really no substitute for electricity. And so as the price of that changes, I would bet that demand is inelastic. Um, if we define something narrowly, like your favorite specific brand of a running shoe, demand for it will be quite elastic as compared with demand for shoes overall. Demand for apples is probably more elastic than demand for fruit, and certainly more elastic than demand for food. And some of that kind of relates to the other types of that good would be substitutes for it. Think about how long of a time frame are we focusing on? That might help answer some things. Let's think about gasoline. And over a long time period, if you knew the price of gas would increase and stay high for a long time, you could structure your life so you didn't use very much of it. So your demand would be quite elastic. But over the course of the next week or month, there's very little you can do if the price of gas increases. You can't probably change where you live or where you go to school or work, and the type of vehicle you have might be something you're kind of stuck with for a while too, if you're expecting to pay that off before you buy a new one. Um, is the good a luxury or is it a necessity? The more of a necessity or addictive or habit forming the good is, then the more likely it is that an increase in the price won't affect buyers. They won't be very responsive. On the other hand, if it's a luxury good that you can go without, then you might be very responsive to a change in the price. If it's a high percentage of your income or your budget, then price change is likely to be felt more, and this might explain why um, car companies are frequently having a sale on cars every time. It's the biggest sale ever, right? And the reason why is because a decrease in price would actually get people to buy a lot more cars because that's a big purchase. Whereas on the other hand, there are some goods that doesn't seem like there ever would be a sale on, probably. Um, for me, I think about here, like, how many paper clips do I buy and use? Well, the number of paper clips I use is totally independent of the price. If I need paper clips, I'll buy them. They're such a small item in my budget, and I don't buy them frequently enough that I'll still just pretty much use them as, as much as I wish. So those are some characteristics of goods with elastic and inelastic demand. Um, we have some more practice examples that we might look at here. Um, Here's a situation where they ask us whether the demand is elastic or inelastic or unit elastic between a couple of prices. And so some strategies we could use to solve that might be to think about here this point and this point as well. So let me mark those points here. If we talked about that one and that one, right, we have a red one here, and then we'll make the other one green. Okay. Now at the green point, we could do P over Q, and that would be 6 over 60 times 1 over the slope, so that's 1 over negative 1/30th. And then we just flip that second fraction around, we'd get negative 180 over 60, or negative 3. When we drop the negative sign, the value of ed right there is 3. If we do the same thing over here, we're going to get a value of negative 1.66. So the value of ed there is like 5/3. Both of those are greater than 1, so this is part of the elastic range of the demand curve. Economists prefer a slightly better way of doing that for a range of the demand curve. And really, we're thinking about this blue section of the demand curve here. So based on this midpoint method we have over here, frequently we can sort of think about defining the ed value for a range of the demand curve by saying it equals the midpoint. So here's the math that would be maybe the very best way of doing that. We could think about what if the price were 5.5, that's the middle, and what if the quantity were 75? We multiplied that by 1 over negative 1/30th. So really, if we do that, we're going to get 165 over 75. And Sorry, that's still negative, I suppose. Once we shake all this out of here, we're going to get negative 2.2, or negative 11 fifths. And if we drop the negative sign, we'd figure out that's elastic as well. We could double check that solution by thinking about what was the total revenue. 6 times 60, 360. What was the total revenue here? 450. And it increased. So that tells us we're in the elastic part of the demand curve. And the explanation there would be your math, your comparison of total revenue values. Um, that's a great way to solve that problem, and it illustrates the importance of that midpoint method as well. I got 5.5 just by averaging 5 and 6, and 75 by averaging the Q values and using those in my P over Q times 1 over slope formula. Um, Here's another one, and we've looked at this one in class because this is one where the AP goofed up a little bit, but we could go down here to part D and think about the elasticity aspect of it. And there's a couple of different ways that we could think about solving that. What ways could we do that? Well, let's think here. Um, we could use the sign of marginal revenue. So at price of 18, that goes along with quantity of 11. You can see MR's down here. The price of 16 goes along with quantity of 12, and MR's down here. So that would tell us demand is inelastic. Or we could use the total revenue test, and we could take 18 times 11, and we'd end up with 198. And we could take 16 times 12, and we can end up with 192. And so we know as we increased quantity, total revenue got smaller. So, this box that's 18 units tall, 12 units, and 11 units wide is actually bigger. So that tells us inelastic as well. Or we could calculate that ED coefficient using that midpoint method. And what would we do there? We would probably say, well, what's that price? That price is going to be 17. And what's that quantity going to be? It's going to be like 11.5, right? And then we want to multiply that by 1 over the slope. Well, the slope is negative 1/2, right? So we're going to multiply that by 1 over negative 1/2. So multiplying that out a little bit. Oh, excuse me, I apologize. The slope is negative 2. And so that'll give us, it's pretty ugly, but negative 17/23. And we know that that's, of course, less than 1 when we take that absolute value. So that's another support for the idea that it's inelastic portion of its demand curve. What we got here? I think this might be about the last slide I've got for you, but you can think here about parts A, 2, and 3, and part C. Okay, so what did I prepare over here? Well, that comes later. For part A, 2, and 3, the way I'm doing the math is I'm thinking about the price elasticity of supply. So what is that? That's percent change in quantity supplied over percent change in price. Pretty messy here. How will I do that? Quantity supplied. Let's see. It went from 1,000 pounds per week to 1,500 pounds per week, which looks like a 50% increase. And that's positive 50%. What happened to price? Well, price went up from $1 to $1.20, and so that's over 20%. So what is that? That's 2.5. That sounds like that is elastic to me. There we go. Applying the price elasticity of supply formula a little bit. Down here, they told us about a cross price elasticity of coffee with respect to muffins. And so I'm thinking that's percent change in quantity demanded of coffee divided by percent change in the price of muffins. And what does that tell me when I work down here a little bit? When the price of muffins increased by 10%, I need to find the change in quantity demanded of coffee, and the answer to that fraction is going to be negative 2. So you might think, well, goodness, that means the amount of coffee we buy has to decrease. Well, of course it decreases because this value is negative, and people enjoy having coffee and muffins together. And that negative value helps you know they're complementary goods. So we want to buy fewer of those. And that means that there's a decrease in demand. And at the new price of muffins, people only want to buy 80 cups of coffee per week. So it's a 10% increase in the price of muffins and a 20% decrease in the amount of coffee demanded. So 80 cups is your answer to that one. And they've helped you out by providing a horizontal supply curve so that you know exactly what that value is. Hopefully this has helped a little bit with understanding elasticity, and I wish you good luck when you encounter problems about elasticity on your test examinations. Thank you very much for watching TCon.